Today we will be going over chapter 6, which is kind of a bridge between probability and statistics. So we are essentially going to learn about the normal distributions and the condition by which a sampling distribution is normal, which is called the central limit theorem. We are also going to look at the normal approximation to the binomial distribution. So let's start first with the normal distribution. It is a continuous random variable which has a density function expressed as this formula, which is kind of a function. And the curve of this function looks like a bell shape. So a normal distribution is bell shape, as you can see here. This is the form of a bell. And approximately 68% of values are within the first standard deviation, as we learned in the empirical rule before. And within 2 standard deviation, we have about 95% of values. And within 3 standard deviations, about 99.7% of values. The Z, or the standard value, is generally used to compute probabilities involving a normal distribution, because there is a table that can always tell us what is the probability that the standard value is less than a certain number, or that the standard value is below a certain value. So in general, when we have questions about a probability, like probability that Z is less than or equals to A, this can be represented on the standard normal distribution as the area to the left of A. So the standard normal distribution gives us the value of this probability. So when we have a general normal distribution X with mean mu and standard deviation Z, we can always standardize the value using this Z formula. Calculators are sometimes useful in computing probability involving the normal distribution. There is a Google calculator for normal distribution also that I will show you, which will be much easier to use most of the time. So, probability is expressed on a graph as the area. When we want to speak about the area to the left of a value X, it is the probability that X is less than or equals to X, as I show you on the whiteboard. When we want to express the area to the right, it is the probability that X is greater than or equals to X. And the area between two values, A and B, is the probability that X is greater than A and less than B. Let me go back to the whiteboard to explain this again. Suppose we want the probability that A is less than or equal to X, less than or equals to B. That actually can be represented on the whiteboard. This is a normal distribution. Let's say here is A and here is B. This probability is the area between A and B. So we can always transform a question about a normal distribution X into a standard distribution by computing the standard value associated with each of the number in the probability. So we have here A minus mu over sigma less than or equal to Z, which is X minus mu over sigma less than or equal to B minus mu over sigma. So the table of the values to the area to the table values correspond to the area to the left of Z. One table gives the area to the left of a negative Z value, and the other table gives the area to the right or the positive values. If you look into your textbook, you can see those tables either on the formula sheet or towards the end. If the formula sheet is no more in your textbook, you can look at this normal distribution table in the page 650. In page 650. So there are two ways to answer question about the normal distribution. Either you read it from the table or you use a normal distribution calculator. So I'm going to show you three methods in doing computation involving a normal distribution. Either you use your TI-83 calculator if you have one, or you use the table at the back of your book, or you use a Google normal distribution calculator. So using a calculator, a TI-83 calculator, we want to find the area to the left of Z. Z equals to 1.99. So you go to second function on your calculator. For those using calculator, you go to second function, and you will see the expression VARS for distribution. And then you go to the second option, normal CDF. And you will enter the value A for the lower value in the probability, B for the upper value in the probability, mu and sigma. For the standard normal distribution, the mean is 0 and the standard deviation is 1. You will not be told anymore. It is just none like that. What we call standard normal distribution, the standard normal distribution has mean 0 and standard deviation 1. So we are going to enter, in the case of left, the area to the left of 1.99, the lower value is negative infinity, that for this purpose, we will enter it as minus 1,000. We are just looking for a very large negative number, minus like 1,000 or minus 100,000, minus 1 million. Any of those can be used for infinity. Then the upper value is 1.99. When you are using the standard normal distribution, you don't need to enter the mean and the standard deviation. For some of you, you have a calculator that has by default the mean to be 0 and the standard deviation 1. That is for the standard normal distribution. So if you do this, you will get a value of 0.9767. Next, we can use a normal distribution table. Let me go to Google. That is another option. I will type standard normal distribution table. So this is a standard normal distribution table like the one at the back of your book. So we want the area to the left of 1.99. Because 1.99 is a positive value, we will go to the positive table. On this table, we are given the area to the left of each standard value that we have. The value is represented by the first decimal, and the second decimal is at the upper part of the table here. For 1.99, we will take 1.9 and then 0.09 up here, and we get 0.9767. 0.9767 is the probability that Z is less than 1.99. We can use the table. We can also use a normal distribution. Sorry for this. We can also use a Google calculator. I'm going to go now for a Google calculator. Standard normal distribution calculator. I will take this first calculator. So with this calculator, we will be able to find probability involving normal distribution in general. For the standard normal distribution, the mean is 0 and the standard deviation is 1. So the two values are, we are looking for the area below 1.99. So I'm going to choose this one, below 1.99. And we have that area to be 0.975. So this is how you can use this calculator, and I will encourage you, if you don't want to always opening your book, to use this calculator for the area to the left, to the right, below, above, between of a normal distribution. So let's continue with the PowerPoint. Each time we have a question, we will use one of those methods to find the area. For example, if we now have the distribution X with mean mu equal to 75 and standard deviation equal to 4, we can also use the calculator to find this by going to second function, distribution, option 2. The lower value is 68, the upper value is 78, the mean is 75, and the standard deviation is 4. So I will enter here 68, comma, 78, comma, the mean is 75, and the standard deviation is 4. So I will have the answers 0.733. The second option is to use either the Google calculator or the binomial distribution. If I want to use the Google calculator here, I will recall that this question is about a standard deviation, is about a normal distribution with mean 75 and standard deviation 4. So the mean here is 75, the standard deviation is 4. The values are between 68 and 78. So I will click the between is the option I'm using, and the answer is 0.733. The last option which we will do is the one using the table. So I will go back to the PowerPoint. So to find this probability using the table, you are going to first convert this in standard form. Yeah, it's not here. I'm going to add it from the whiteboard. You already have, either you use TI-83 calculator or you use the Google calculator to find this answer. But if you are doing it manually and you want to read the table, we are going to say mu is 75, sigma is 4, and we want the probability that 68 is less than x, less than 78. So what we will do is that we will find the z form. This is 68 minus 75 divided by 4, less than or equals to z, less than or equals to 78 minus 75 over 4. 68 minus 75 is divided by 4. Minus 7 divided by 4 is minus 1.75. And 78 minus 75 is 3 divided by 4 is 0.75. So using the table, for those who want to use the table, you will do probability that z is less than 0.75 minus probability that z is less than negative 1.75. So to find the probability that z is less than 0.75, we will use the normal distribution table. So we'll start with 0.75. This is 0.7 here, 0.75 we get here is 0.7734. And negative 0.7734, I need to put that back there. Zero point 7734. Now minus negative 1.75. We'll go back to the table for negative 1.75. Negative 1.7 is here. And we are going to look for where 5 is. And we have 0.0401 minus 0.0401. So going back to the whiteboard, 0.0401, and this is 0.733. We use this method because you don't want to use a calculator or you don't want to use the Google calculator. So, as I told you, you have three ways of finding either the area or the probability. It is either called area or probability. Is area to the left, to the right, or you can say area below, area above, or you can say area between or area outside, depending on the nature of the question you have. You can use the Google calculator that I show you. You can use the TI-83, 84 calculator. You can use the table. The most difficult is the table because you have to do the conversion when X is not a standard, because that table is only for standard normal distribution. Sometimes you have question about the Z value, so that the area to the left, the area to the right, or the area, you are given the area and you want to find the Z value. We call that the inverse normal distribution. For example, if you are asked to find the Z so that the area to the left of Z is 0.05, you can use your TI-83 calculator or you can use the standard table. To use the TI-83, you will do second function and choose the third option, which is inverse normal. With inverse normal, you can just enter the area 0.05 and you will get negative 1.6. The third option, just enter 0.05, enter, you will get negative 0.1645. Now let's do the same question from the normal distribution table. The normal distribution table is here. We want Z so that the area to the left of Z is 0.05. So we will look into the probability for 0.05. So we have 0.05 here. We have 0.0495 here. So is it between these two numbers? So these two numbers are equally distant from 0.05 as the probability. So the Z value is negative 1.6, either 64 or 65. We will take the middle and we will say negative 1.645. So the area, you find the area into this table. So we can have this type of problem also for a regular normal distribution. For a regular normal distribution, we may want to find the value of X so that the area to the left of X is 0.05. When mu equals to 75 with standard deviation 4. To do this, we are going to look into the Z distribution table to find the Z value so that the area to the left of Z is negative, the area to the left of Z is 0.05. We get that value to be negative 1.645. The formula for X is X equal to Z sigma plus mu. So we'll do negative 1.645 times sigma, which is the standard deviation, plus 75, which was the mean, and we will get 68.42. For those of you who have a TI-83 or 84 calculator, you can go to second function and choose the third option, inverse normal. Then enter 0.05, then the mean, 75, and the standard deviation. You will get 68.42. So using the TI-83 is much easier, but you can also use the table. So in several homework questions, you will be asked this type of question problem. Find the area to the right of z equal to negative 1.16. You can use your calculator, taking negative 1.6 as the lower value and maybe 1000 as the upper value to get the answer. But you can also find the area to the left of negative 1.6, negative 1.16, and subtract it from 1, which is what I will do. So we go back to the normal distribution table. Standard normal distribution table, and we are looking for negative 1.16. Here is negative 1.1. And we have 0.123 as the area to the left of negative 1.12, of negative 1.16. What I'm saying is, we have here negative 1.16, and we are asked to find the area to the right of negative 1.16. From the standard table, this area is 0.123. So the area to the right is 1 minus that, which is 1 minus 0.1. It is 0.1 minus 0.123 equals to 0.877. This is for using the table for area to the right. Find area to the right, find the area to the left, and subtract it from 1. You could use the Google calculator for this as well. The Google calculator, we want area to the right or area above. Area to the right of negative 1.16. We have to change this. Always remember to change this. If it is the standard, the mean is 0. And the standard deviation is 1. When you hear standard table, the mean is 0 and the standard deviation is 1. Now, suppose we want to find the area between 1.68 and find the area between z equals to 1.68 and negative 1.34. So this is the area we are looking for. It's easier to use the Google calculator here. And remember, it's negative 1.37 and 1.68. So I'll go back to the Google calculator because it is the easiest method to find area. Use Google calculator, and we will choose between. Because it is standard, we keep the mean to be 0 and the standard deviation to be 1. So here is negative 1 point, negative 1.37 and 1.68. So we have 0.8682. 18682, you can use the Google calculator to find the area. I will advise you to use Google calculator to find the area and to use the table to find the inverse normal. Find the z-value such that the area under the standard normal distribution curve between 0 and z is 0.2123. Remember that the area that we get from the table is the area to the left of z. If we know that the area between 0 and z is 0.2123, then the area to the left can be obtained by adding 0.5 to it. So the cumulative area will be 0.7123. You can use your Google calculator with inverse normal and enter 0.7123. So if you enter 0.7123, you will get 0.56. But we can go back to the standard normal distribution table. I told you when you want to find z given the area, it's easier to use the standard table. The standard table is here. The area that we were given was the area between 0 and z is 0.2123. And we realized that the table is giving us the area to the left of z, as you can see it here. That's the tail to z, that's what is given here. And if we are between 0 and z, the area below 0 is 0.5. We add it to 0.2123 to get 0.7123. So I will be looking for 0.7123. 0.7123. This is 0.7123. And the z value, so that the area to the left of z is 0.7123, is 0.56. So that's how we can get it using the table. These are the type of questions you will have on your homework or your quizzes. You will be asked to find z so that the area to the left, area to the right, area between, or find the area so that z is less than, greater than, or between. So we are going to look at some problems involving the normal distribution now. A survey by the National Retail Federation found that women spend on average 146.21 for the Christmas holidays. Assume the standard deviation is 29.44. Find the percentage of women who spend less than 160. Here we are going to use the Google calculator to find the probability that X is less than 160. Remember at this point that the mean is 146.21 and the standard deviation is 29.44. We want to find the probability that X is less than 160. So for this question, the mean is 146.21. The standard deviation is 29.44. And we want to find the probability that X is less than or equal to 29.44. We can say this is equal to probability that Z is less than, sorry, not 29.44. It was 160. 160. So we do 160 minus 146.21 divided by 29.44. So this is 160 minus 146.21 divided by 29.44. So this is equal to the probability that Z is less than or equals to 0.47. So if you are using Google Calculator, you do not need to do this transformation. That is why I'm encouraging you to use the Google Calculator. You do this transformation only if you want to use this distribution table. So now with the distribution table, we want the probability that Z is less than 0.47. Z is less than 0.47. This is 0.4 here. Z is 0.47. 0.47 is 0.6808. 0.6808. Now, 0.68, we want to now use we can use the calculator. Normal CDF, we want the probability that X is less than 160. We can start with the lower value as 1 million or 1,000 or 100,000, any very large negative number. Then 160, then 146.21. Then the standard deviation is 29.44. And we will still get 0.680. We get 0.6802, which is close to that. Now let me use the Google calculator. The mean for the Google calculator, the mean is 146.21. 146.21. The standard deviation, 29.44. So we want the probability that X is below 160. And we get 0.6803. So you can either use a calculator, either the Google calculator or the TI-8384 calculator, or you read the table to answer questions about probability. Let's look at this other problem. Each month, an American household generates an average of 28 pounds of newspapers for garbage or recycling. Assume the standard deviation is 2 pounds. If a household is selected at random, find the probability of it generating between 27 and 31 pounds per month, assuming the variable is approximately normally distributed. So we have here, we can use calculator. Let's start with calculator. We do second function, distribution, option 2 for normal CDF. We want the probability between 27 and 28. The lower value is 27. The upper value is 31. the mean is 28, and the standard deviation is 2. So we have the probability to be 0.6247. If you want to read the table, you will transform both numbers into standard form, and the question will be to find the probability that the z distribution is between negative 0.5 and 1.5. So reading from the table, the probability for 1.5 is 0.9332, and the probability for negative 0.5 is 3085. Take the difference to get the probability. You can also use your Google calculator. With the Google calculator, here we have the mean was 28. The standard deviation was 2. We were dealing with probability between 27 and 31. And we have 0.6247. As you can observe, for questions involving probability or area, using the Google calculator is much easier. So now let's look at another type of problem. An American Automobile Association report that the average time it takes to respond to an emergency call is 25 minutes. Assume the variable is approximately normally distributed and the standard deviation is 4.5 minutes. If 80 calls are randomly selected, approximately how many will be responded to in less than 15 minutes? Here is the inverse, I'm sorry, not the inverse. Here is finding the probability that a call is answered in less than 15 minutes and multiply it by 80 like in a binomial distribution problem. Approximately how many calls will be responded to in less than 15 minutes? We first need to find the probability that X is less than 15 minutes. And I will use the Google calculator for this one with a mean of 25 and a standard deviation of 4.5. Here I will change the mean to 25 and the standard deviation is changed to 4.5. Now we want below 15. So the probability that a call will be answered is less than 15 minutes is 0.0131. Now, if there are 80 calls, the number of calls that will be answered in less than 15 minutes will be 80 times 0.0131, which is 1.048. So approximately one call will be answered in less than 15 minutes. Let's do an example for inverse normal. To qualify for a police academy, candidates must score in the top 10% on a general abilities test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume the test scores are normally distributed. The lowest possible score is the score to the top right of the distribution, from which the probability that a score is above is 10%, which is 0.1. In other words, we want to find X so that area to the right of X is 0.1. If you have a TI-83 calculator, you will get this quickly. Using the inverse normal, you have the area 0.1. The area we have here is the area to the right. So we have to use 1 minus area to the right, that is 0.9 from the calculator. And then the mean is 200. The standard deviation is 20. So the minimum score will be 226. So another way to resolve this is to use the formula with the standard normal distribution table. With the standard normal distribution table, remember that we are looking for z so that the area to the right of z is 0.1, meaning that the area to the left of z is 0.9. If you look at the table, you will identify this probability as the closest to 0.9. So for that reason, the z value corresponding to it will be 1.28. So we are going to multiply using the formula x equals to mu plus z sigma, 200 plus 1.28 times 20 equals to 225.6. We will round it up to 226 to determine the minimum score so that 10% of values are above 226. Another type of question is this one. For a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. If the mean systolic blood pressure is 120 with a standard deviation of 8, find the upper and lower reading that will qualify people to participate in this study. Here we are looking for the area at the middle. When you look at the area at the middle, identify those two values with area at the middle, and then you will use the area to the left and area to the right to be able to read the normal distribution table. So we will determine that the area to the left of the z is we know that area to the left here is 0.3. So below x1, the area is 0.8. So the area is 0.8. To find the z value corresponding to x1, we will find the inverse area with 0.8. And we look into the standard normal table for 0.8. So this is the value closest to 0.8, 0.84. This probability is the one closest to 0.8. The z value corresponding to it is 0.84. While we are here, we are going to look at this lower value. The area to the left of the lower value is 0.2. So we are going to look at z value corresponding to 0.2. So we are here. And this is 0.2, negative 0.84. So the two z values that we need to enter into the formula for the lower value is negative 8.4, negative 0.84, and the upper value is negative is 0.84, negative 0.84 and 0.84. We go back to the PowerPoint to apply it to the formula. So applying 0.84 to the formula, we got x equals to mean plus sigma z, and we get 126.72. Now for the negative part, we will get x equals to 120 minus 0.84 times 8, and we get 113.28. So the two values, the individual that could be selected are those whose readings are between 113 and 127. For those using calculator, you can use the inverse normal for 0.2 and the mean of 120 and standard deviation of 8, and do the same for the upper values, and you will get the same result. So as we have seen so far, a normal distribution is a distribution with a mound shape, a bell shaped, which is symmetric with respect to the mean. The mean, the mode, and the median are the same, and they are very useful in statistics. There are many methods in determining if a distribution is normal or not. One of the common one is to make a histogram of a sample from that population. And if the histogram is normal, we can assume that the distribution is approximately normal. Now we look at the central limit theorem. The central limit theorem considered the distribution of mean or proportion. What happened here is this: the connection between probability and statistic is that we define a random variable by selecting random samples and computing either the mean, and we will define the random variable of sample mean, and the distribution is called the sampling distribution of sample mean. So if your probability experiment consists of taking a random sample, you can compute the mean and call it the sampling distribution of sample mean, or the sample proportion, I'll call it the sampling distribution of sample proportion. Our question is, what is the nature of the distribution of sample means? The distribution of sample mean will be normal if the population is normal. But when the population is not normal, we will require that the sample size is at least 30 for this distribution of sample mean to be normal. In addition, the mean of the distribution of sample mean is the same as the population mean, and the standard deviation of the distribution of sample mean is the standard deviation of the population divided by square root of n, when n is the sample size. So these two information are very important when question will be asked about the sample mean. The mean is the same as the population mean. The standard deviation is the population standard deviation divided by square root of n. So when we have that, the standard score for sample mean will be sample mean minus population mean divided by population standard deviation over square root of n. Essentially, whenever you have a question which asks about the probability for the sample mean, just readjust the standard deviation and do the same thing as we were doing before. This is an example. AC Nelson reported that children between the ages of 2 and 5 watch an average of 25 hours of television per week. Assume the variable is normally distributed and the standard deviation is 3 hours. If 20 children between the ages of 2 and 5 are randomly selected, find the probability that the mean of the number of hours they watch television will be greater than 26.3. So here we are dealing with the sample mean of 20 individuals. So n equals to 20. The next thing to do is to find the standard error, which is finding standard deviation divided by square root of n. That is 3 over square root of 20. And then we proceed the same as we were doing before. So the standard error here will be 3 over square root of 20, which is the standard deviation of the distribution divided by the square root of the sample size. And we here want to find the probability that the sample mean, here is actually the sample mean, is greater than 26.3. You can use the calculator, you can use the Google calculator, and that's what I will use now. The mean is 25. The standard deviation now is 0.67, which is 3 over square root of 20. So we say here that the mean is 25 and the standard deviation is 0.67. I will use the Google calculator for this one. The mean is 25. the standard deviation is 0.67. And we want the score to be above, we want the score to be above 26.3. So we have the answer 0.0262. 0.0262. So if you are using your TI-8384 calculator, you will enter 26.3 as lower value, 1000 as upper value, and 25, 0.67 to get a probability of 0.0262. An average age of a vehicle registered in the United States is 8 years. Assume the standard deviation is 16 months. If a random sample of 36 vehicles is selected, find the probability that the mean of their age is between 90 and 100. Again, here the question is about the mean. So we are going to find a new standard deviation by dividing it by the square root of the sample size, which is square root of 36. So 8 divided by 6. So we are going to have used this formula. Here, the standard deviation was 16, and the sample size is 36. We do 16 over square root of 36. And we can use either the Google calculator with a mean of 96 and a standard deviation of 11 over 16 over square root of 36, which is square root of 36 is 6. 16 divided by 6, 2.67. So we have here that the mean is 96. The standard deviation is 2.67. And we want the probability that the sample mean is between 90 and 100. We have 0.9206. Yeah. The average number of pounds, I'm doing several examples. Hopefully you will understand the difference between the normal distribution and the normal distribution for the mean. The average number of pounds of meat that a person consumes per year is 218.4 pounds. Assume that the standard deviation is 25 pounds and the distribution is approximately normal. Find the probability that a person selected at random will consume less than 224 pounds per year. With this question, we can use the Google calculator with mean of 218.4 and the standard deviation of 25. We want the probability that X is less than 224. $218.4 is the mean. The standard deviation is 25. We want to find the probability that the amount consumed is less than 224. Below 224. We will have 0.56, 588 or 0.6. From the Google calculator, we have 0.6. Here you have 0.558. So now the next question will be the average number of pounds of meat that a person consumes per year is 218.4 pounds. Assume that the standard deviation is 25 pounds and the distribution is approximately normal. If a sample of 40 individuals is selected, find the probability that the sample will be less than 224 pounds per year. So here the mean again is 218.4, but the standard deviation has changed to, because it is a sample mean, so we'll do 25 divided by square root of 40. The standard deviation is now 395. Let's go back to our Google calculator. For the same question, what is going to change here is the standard deviation. Okay, we are here. The standard deviation is no more 25, it is 3.95. And we have the same question, and the probability is now 0.92. So we can use the Z distribution table to find Z equal to 1.47 and the area is 0.9. Another application of the normal distribution is for binomial distribution. In binomial distribution, we often have situations in which the sample size is very large, and we want to use the normal distribution to answer questions about the binomial. The condition for a binomial distribution to be approximately normal is that n times p is greater than or equal to 5, and n times q is greater than or equal to 5. So in order to use the normal distribution to answer questions about a binomial distribution, we often make what we call a correction for continuity. Here, if the binomial distribution question is x equals to a, we will transform it into probability that x is greater than a minus 0.5, a plus 0.5. If x is less than a is the binomial distribution question, we will work it as a normal distribution and consider x greater than a minus 0.5. And if x is greater than a, we will consider it as x is greater than a plus 0.5. The main idea here is to look into the values that are in the event. When we say x equals to a, then we can shift left and right by 0.5. When we say x is less than a, for example, x is less than 3, it means it starts from 2. So you will decide either to add or to subtract 0.5 to 3. If you add, you will get 3.5 and you will be pushing 3 into the event. So it's better to do x is less than 2.5. If you have x is greater than a and a is 3, for example, x greater than 3 means that it starts from 4. So it's better to do 3.5 and above. The mean for a binomial distribution is NP. the standard deviation is square root of NPQ, which we knew before. So let's look at some example. A magazine reported that 6% of American drivers read the newspaper while driving. If 300 drivers are selected at random, find the probability that exactly 25 say they read the newspaper while driving. So we will find that the mean NP is 300 times 0.06 equals to 18, and NQ is 300 times 0.94 equals to 282. Now, since NP is greater than or equals to 5 and NQ is greater than 5, we can use the normal distribution here with a mean of 18 and a standard deviation of square root of NPQ, which is 4.11. Having that, our equation of x equals to 25 will be transformed into x greater than 24.5 and less than 25.5. So we can use the Google calculator now with the mean of 18 and a standard deviation of 4.11. The mean of 18, the standard deviation of 4.11. We are between 24.5 and 25.5. So the probability will be 0.057. 0.057. Let me check this one again. 24.5. We say the mean is 18, the standard deviation is 4.11. We can also use our TI-83 calculator. Second option, 24.5, 25.5, the mean of 18, the standard deviation of 4.11. It is 0.228. What happened here? This calculator did not give us the right answer. Let me look back at the Google calculator. Yeah, the answer is 0.0229. Let's look at another question. Of the members of a bowling league, 10% are widows. If 200 bowling league members are selected at random, find the probability that 10 or more will be widowed. So we'll first check if we can use a normal distribution here. We do n times p, p is 0.1, n is 200, we get 20, n times q, 180. Both numbers are bigger than 5, so we can use a normal distribution for this binomial problem. The mean is NP equals to 20. The standard deviation is square root of NPQ, which is 4.24. Now we want the probability that x is greater than or equals to 10. We need to convert it first by adding or subtracting 0.1 to maintain the same random variable. So x is greater than or equals to 10. If we add 0.5, we will do 10.5, which is not the right thing. We will subtract 0.5 instead, and we will get x is greater than 9.5. Remember here, the mean is 20, and the standard deviation is 4.24. I will go back to the Google calculator. Google calculator here, and we have a mean of 20 and a standard deviation of 4.24. The mean is 20, the standard deviation is 4.24. We want x is above 9.5. X is above 9.5. So we have x is above 9.5, 0.9934. Using the TI-83 calculator, you will go second function distribution, second option. We want above 9.5. So the lower value is 9.5, the upper value we can take 1,000. And then the mean is 20. The standard deviation, 4.2. So we have 0.993. That is 99.34% are above 10. More than 10 people are widowed. So these are instructions on how to use calculator, how to find the Z value. So we are done with chapter 6. You can do the homework, and if you have questions, send me an email.